Hi everyone, myself Dr. Binsi, and today we are going to discuss standard sum of product, in short standard SOP, and standard product of sum, in short standard POS. Standard forms of Boolean expressions. All Boolean expressions, regardless of their form, can be converted into either of two standard forms. Sum of products, that is SOP form, and product of sums, that is POS forms. Standardization makes the evaluation, simplification, and implementation of Boolean expressions much more systematic and easier. Sum of products, that is SOP. The sum of product form. An SOP expression when two or more product terms are summed by Boolean addition. For example, AB plus ABC, ABC plus CDE plus B bar CDE bar, then A bar B plus A bar B C bar plus AC, and also A plus A bar B bar C plus B C D bar. Here consider the first example. Here the product terms are AB and ABC and it is summed. That is, this is the sum of product term. And one more point important to remember is, in an SOP form, a single overbar cannot extend over more than one variable. However, more than one variable in a term can have an overbar. For example, A bar, B bar, C bar is okay, but not A, B, C the whole bar. General expression of SOP. Any logic expression can be changed into SOP form by applying Boolean algebra techniques. For example, A into B plus CD. Here we are going to convert this into SOP form, general expression of SOP. So for that you should take A inside the bracket. So what we will get is AB plus ACD. This is an SOP form. And consider the second example, AB plus B into CD plus EF. Here we should take this B inside the bracket. So what we will get as final SOP is AB plus BCD plus BEF. Here also A plus B into B plus C plus D. Multiply these two terms. What we will get is AB plus AC plus AD plus BB plus BC plus BD. That is the final SOP. Next, A plus B bar plus C the whole bar. Here we should apply De Morgan's theorem, that is A plus B the whole bar is equal to A bar dot B bar. But in the place of A, here we have A plus B the whole bar, and in place of B, here we have C. So the expression after applying De Morgan's theorem, this will become A plus B bar the whole bar dot C bar. Double bar, it is cancelled. That is, double complement means that term itself, that is A plus B into C bar. For getting final SOP, we should take the C bar inside the bracket and the final expression becomes A C bar plus B C bar. Next, our topic, that is standard SOP form. A standard SOP expression is one in which all the variables in the domain appear in each product term in the expression. That is, consider this example, A B bar C D plus A bar B bar C D bar plus A B C bar D bar. Here this is a 4 variable term. The variables are A, B, C and D. In all the terms, all variables are present. So this is a standard SOP form. So a standard SOP expressions are important in constructing truth tables. And also the Carnot map simplification method, that is, this Carnot map you will study in the later class. Next, converting product terms to standard SOP. The step 1, multiply each non-standard product term by a term made up of the sum of a missing variable and its complement. The result, this results in two product terms. As we know, we can multiply anything by 1 without changing its value. For example, in a term, if the variable A is missing, you should multiply that term with A plus A bar. In effect, you are multiplying that term with 1 which does not change its value. Next, step 2, repeat step 1 until all resulting product term contains all variables in the domain in either complemented or uncomplemented form. In converting a product term to standard form, the number of product term is doubled for each missing variable. So let us do one example. Convert the following Boolean expression into standard SOP. Here A B bar C plus A bar B bar plus A B C D. Here it's a 4 variable term. So it should contain A, B, C and D in all the terms. But here D variable D is missing, and here variables both C and D are missing. So consider this term, that is A, B bar, C, and here D is missing. So you should multiply this term with D plus D bar. In effect, you are multiplying the value of D plus D bar is equal to 1. That is, in effect, you are multiplying this term with 1, which does not change its value. And next step is you should multiply. You should take this inside the bracket. What we will get is A bar CD plus A B bar C D bar. Now consider the second term A bar B bar. So A bar B bar into C plus C bar. First here both variables C and D they are missing. So first we should make it a C variable. So A bar B bar C plus A bar B C bar. So we get two terms. Next is we should multiply this with D plus D bar. So A B bar C into D plus D bar, A bar B bar C bar into D plus D bar. So multiply, what we will get is A bar B bar C D. It is A bar B bar C D. Next A bar B bar C D bar, A bar B bar C D bar. Next A bar B bar C bar D, A bar B bar C bar D, and last A bar B bar C bar D bar, this term. And the final standard SOP expression is this is that is A B bar C D plus A bar C D bar, and this one A bar B bar C D plus A bar B bar C D bar plus A bar B bar C bar D plus A bar B bar C bar D bar, and also this term, that is A B C bar D. This is the final standard SOP form. Next, product of sums or POS. When two or more sum terms are multiplied, the resulting expression is a POS. Examples: A bar plus B into A plus B bar plus C. Example 2, A bar plus B bar plus C bar into C plus D bar plus E into B bar plus C D. Next, A plus B into A plus B bar plus C into A bar plus C. Here these are the sum term, that is A bar plus B, A plus B bar plus C, and it is multiplied. That is this is the product of sum form. And also last example, A bar into A bar plus B bar plus C into B plus C plus D bar. It's also a POS. In a POS form, like in SOP, as we discussed in the last earlier slide, a single overbar cannot extend over more than one variable. However, more than one variable in a term can have an overbar. For example, A bar plus B bar plus C bar is okay, but not A plus B plus C the whole bar. The standard POS form. A standard POS expression is one in which all the variables in the domain appear in each term in the expression. For example, A bar plus B bar plus C bar plus D bar into A plus B bar plus C plus D into A plus B plus C bar plus D. Standard POS expressions are important in constructing truth tables and also the Carnot map simplification method. Here in this example, it's a 4 variables present, that is A, B, C and D. In all the terms, all the variables are present. So this is a standard POS form. Next, converting a sum term to standard POS. Step 1. Add to each non-standard product term and a term made up of the product of the missing variable and its complement. This results in two sum terms. As we know, we can add 0 to anything without changing its value. For example, in a term, if variable A is missing, you should add that term with A and A bar. In effect, you are adding that term with 0, which does not change its value. And step 2, we should apply a rule, that is A plus BC is equal to A plus B into A plus C. It's an important rule and we should apply in this case. Step 3. Repeat step 1 until all resulting sum terms contain all variables in the domain in either complemented or uncomplemented form. Next, we can do one example. Convert the following Boolean expression into standard POS form. Here there are 3 terms here: A plus B bar plus C, then A B bar plus C plus D bar. Here A plus B bar plus C bar plus D. Here this is a perfect one because all the variables A, B, C and D are present. Here D is missing and here A is missing. So take this one, and as we said earlier, we should add this term with D bar. in effect the value of d bar is equal to 0. That is, you are adding this term with 0. That is, your answer won't change. And apply the rule. That is, a plus cd is equal to ab. That is this rule, that is a plus bc is equal to a plus b into a plus c. Here, that is this d bar, a plus bc is equal to a plus b into a plus c. In terms of b, here d, the a plus a bar plus c in terms of this full term in terms of a, and d in terms of b, and d bar in terms of c. So a plus b, that is, this is full a, that is a plus b bar plus c plus d, and into a plus b bar plus c plus d bar. That is, here you apply the rule a plus bc is equal to a plus b into a plus c. Okay, then b bar plus c plus d bar, here the term a is missing, so we should add this term with a plus a bar. Here it is, and you should apply the rule a plus bc is equal to a plus b into a plus c. That is, the final term becomes a plus b bar plus c plus d bar. That is, a b, this whole terms in terms of in the place of a, that is b bar plus c plus d bar is a, and here a is b and a bar is c. Okay, that is a plus bc is equal to a plus b into a plus c. That is a plus b bar plus c plus d bar, and a bar plus b bar plus c plus d. And the final term, it is we can write as such because all variables are present, and the final standard POS term is equal to a plus b bar plus c plus d plus into a plus b bar plus c plus d bar into a plus b bar plus c plus d bar into a bar plus b bar plus c plus d into a bar plus b bar plus c bar plus d. That's the final standard POS term. Now, conversion of SOP to POS and also POS to SOP. Converting standard SOP to standard POS. That is, the points we should remember is the binary values of the product term in a given standard SOP expressions are not present in the equivalent standard POS expression. The binary values that are not represented in the SOP expressions are present in the equivalent POS expression. So these are the 3 steps. Step 1, evaluate each product term in the SOP expression, that is, determine the binary numbers that represent the product terms. Step 2, determine all the binary numbers not included in the evaluation in step 1. Step 3, write the equivalent sum term for each binary numbers from step 2 and express in POS form. Let us do one example. Convert the SOP expression to an equivalent POS expression. This is an SOP expression, that is a bar b bar c bar plus a bar b c bar plus a bar b c plus a b bar c plus a b c. Now, just recall what we studied as in min terms and max terms. So this represents 0 0 0. So SOP means min terms. So 0 0 0. Complement means 0. Not complement means it's 1. So 0 1 0, and a bar means 0 bc 1 1. Next is 1 0 1, and ABC is 1 1 1, which represents M0 plus M2 plus M3 plus M5 plus M7. That is sigma M 0 2 3 5 7. So these are there are 8 possible combinations since there are 3 variables. So possible number of combinations number is equal to 2 raised to 3, that is equal to 8. Which are M0, M1, M2, M3, M4, M5, M6 and M7. So the SOP expressions contain 5 of these, that is 1, 2, 3, 4, 5, that which respectively M0, M2, M3, M5 and M7 min terms. So the POS, that is max terms capital M, contains the other 3 which are 001, 100 and 110, which is not present here. So which corresponds to the max term. So it is a product of sum a plus b plus c bar. Here 0 means it is not complemented and 1 means it is complemented in POS and also max term. and 100 corresponds to A bar plus B plus C, and 110 corresponds to A bar plus B bar plus C, which corresponds to M1, M3, M4. Okay, while representing max term, we should represent like this since it is POS. So which is represent M146. Boolean expressions and truth tables. All standard Boolean expressions can be easily converted into truth table format using binary values for each term in the expression. Also, standard SOP or POS expressions can be determined from the truth table. So, converting SOP expressions to truth table format. Recall the fact, an SOP expression is equal to 1 only if at least one of the product term is equal to 1. So while constructing truth table, we should do all the 3 steps, that is, list all possible combinations of binary values of the variables in the expression. Step 2, convert this SOP expression to standard form if it is not already. And step 3, place a 1 in the output column X for each binary value. That makes the standard SOP expression a 1, and place 0 for all the remaining binary values. So let us develop a truth table for standard SOP expression. This is the question, that is A bar B bar C plus A B C bar. So A B bar C bar plus A B C. So you should construct a truth table. This is 3 variable, so 8 possible conditions, that is 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and finally 1, 1, 1. And this is the output and the product term. The product terms are A bar B bar C plus A B bar C bar plus A B C. So A bar means in SOP means 0. So 0, 0, 1. So you should enter product term here, that is A bar B bar C, that is 0, 0, 1. Next is A B bar C bar 1, 0, 0, 1, 0, 0. Next A B C means last term 1, 1, 1. And you should enter 1 corresponding to this. Next step is you should enter in the output column 1 corresponding to the expressions, that is product term. And finally enter zeros to the rest columns. So this is your answer. It's over. And I will explain once more. This is your question, and you should enter the product term first, and this in the output term it corresponds to 1, and you should enter remaining column by 0. Next, converting POS expressions to truth table format. Recall the fact, a POS expression is equal to 0 only if at least one of the product term is equal to 0. So while constructing truth table, you should follow 3 steps. Step 1, list all possible combinations of binary values of the variable in the expression. Step 2, convert the POS expression to standard form if it is not already. And step 3, place a 0 in the output column for each binary value. That makes the standard POS expression a 0, and place 1 for all the remaining value. Let us do one example. Develop a truth table for the standard SOP expression. Okay, so if it is not standard, first you should make it standard, as we already did. So here it is standard, so it's also a 3 variable, so 8 possible combinations, and the terms are A plus B plus C, A plus B bar plus C, A plus B bar plus C bar, A bar plus B C bar, A bar plus B bar plus C. So first you should enter sum term here. So this is the sum term, sorry, it's a product term written. So it's a sum term. So A plus B plus C, A plus B bar plus C, A plus B bar plus C bar, A bar plus B plus C bar, and A bar plus B bar plus C. So you entered all the sum terms in the column, and the output you should enter 0. Okay, corresponding to this term 0. So in POS, A, B, C corresponds to 0, 0, 0, and complement corresponds to 1, that is 0, 1, 0. That is 0, 1, 0. Next step is you should fill the remaining column with 1. It's over. Next, determining standard expression from a truth table, the reverse thing. To determine the standard SOP expression represented by a truth table, instructions. Step 1, list the binary values of the input variable for which the output is 1. Step 2. Convert each binary value of the corresponding product term by replacing each 1 with the corresponding variable and each 0 with the corresponding variable complement. For example, 1010 means A, B bar, C, D bar since it is SOP. Now determining standard expression from a truth table. To determine the standard POS expression represented by a truth table. Instructions. Step 1. List the binary values of the input variable for which the output is 0. Step 2. Convert each binary value of the corresponding product term by replacing each one with the corresponding variable complement and each 0 with the corresponding variable. For example, 1001, that is A bar plus B plus C plus D bar. Now let us do the example. Determining standard expression from a truth table. Okay, so these are the input A, B, C, and 3 variable, 8 possible combinations. Here X is the output term, and we already given the output 0, 0, 0, 1, 1, 0, 1, 1. Now first SOP. SOP, that is, there are 4 ones. You should check how many ones are here. There are 4 ones and the corresponding binary values are 0, 1, 1, 1, 0, 0, 1, 1, 0 and 1, 1, 1. Okay. Next step, 0, 1, 1 means in SOP 1 corresponds to 0 corresponds to complement and 1 corresponds to the normal term. So 0, 1, 1 means A bar, B, C. 100 means A, B bar, C bar. 110 means A, B, C bar. And 111 means A, B, C. Now, the final standard SOP term is X is equal to A bar, B, C plus A, B bar, C bar plus A, B, C bar plus A, B, C. Now, let us do POS. POS, first, you should check how many 0 outputs are here. Here also 4 0 outputs and the output which corresponds to the binary value 0, 0, 0, 0, 0, 1, 0, 1, 0 and also 0, 1, 0, 1. So write all these terms and 0, 0, 0 corresponds to A plus B plus C, 0, 0, 1 corresponds to A plus B plus C bar, 0, 1, 0 corresponds to A plus B bar plus C, and 101 corresponds to A bar plus B plus C bar. Now the final POS, standard POS expression is A plus B plus C into A plus B plus C bar into A plus B bar plus C into A bar plus BC. Next, minterms to max term. Use max term that are in the minterm expression, that is f of ABC which is equal to sigma minterm small m 1, 3, 5, 6, 7 which is equal to sigma capital M with 0, 2, 4. This 0, 2, 4 it is not here. So max term to minterm, that is use minterm that are in the max term expansion, that is M 0, 2, 4 is equal to here 1, 3, 5, 6 and 7 it's mixing. So minterm 1, 3, 5, 6, 7. Let us do one example. Convert the following expression to other canonical form. That is this minterm M 1, 4, 5, 6, 7. From the question itself you can find the answer, that is here 0, 2 and 3 terms are missing. So that will be your max term. So let us do the steps. The given Boolean function is x is equal to m 1, 4, 5, 6, 7 which is equal to m1 plus m4 plus m5 plus m6 plus m7. Since it's a 3 variable, 8 possible combinations are there. The complement of the given function is given by x bar is equal to m 0, 2, 3. That is, bar means the terms which are not here. It is equal to m0 plus m2 plus m3. So to find x, you should apply De Morgan's theorem. So x bar, the whole bar is equal to this one m0 plus m0 plus m2 plus m3 bar. That is a plus b plus c, the whole bar is equal to a bar dot b bar dot c bar. This term is here, that is m0 bar dot m2 bar dot m3 bar, which is nothing but max term M0, M2, M3, and you should write in the form that is x is equal to sigma max term capital M 0, 2, 3. Now convert the following expression to other canonical form. That here max term is given M 0, 1, 2, 3, 4, 6, 12. It's a 4 variable, so 16 combinations are possible. That is 2 raised to 4, which is equal to 16 from 0 to 0. That is M0, M1, M2, M3, M4, M5, M6, M7, M8, M9, M10, M11, M12, M13, M14, M15 up to M15 terms we will get. So M is equal to M0, M1, M2, M3, M4, M6, M12. Okay, you should write. And the complement is given by the terms which are not present here are 5, 7, 8, 9, 10, 11, 13, 14 and 16. The terms which are not here. And you should write in form that is M5, M7, M8, M9, M10, M11, M13, M14 and M16. Now next step, it's applying De Morgan's theorem. So x bar the whole bar, that is x is equal to this thing the whole bar, that is a dot b dot c the whole bar is equal to a bar plus b bar plus c bar. Okay, applying this here, you will get M5 the whole bar plus M6 bar, M7 bar plus M8 bar plus M9 bar plus M10 bar plus M11 bar plus M13 bar plus M14 bar plus M15, which is nothing but the min term M5 plus M7 plus M8 plus M9 plus M10 plus M11 plus M13 plus M14 plus M15. That is, now express this in the standard form. That is x is equal to sigma min term M5, 7, 8, 9, 10, 11, 13, 14 and 15. So today we discussed standard sum of product and standard product of sum, their conversion, and how to write standard POS and SOP from truth table, and if the expression is given, how to construct a truth table. Now the conversion, that is SOP to POS and POS to SOP. Hope you all understood. Thank you.